Hi guys, and welcome to today's video on adding fractions, part of our Year 8 series. Oh, could maths get any more exciting? Okay, so adding fractions. I don't know about you guys, but when I was at school, fractions was a dirty word, and I'm imagining it always actually still is, and I'm so sorry about that. But when I've said so many times before, at primary school you undoubtedly did not like fractions. I get it. I genuinely do. But don't worry about it. You are now 4 years older, and I promise you, you can do this stuff. The big thing about fractions is that it requires your times tables, particularly when you've got different denominators and all sorts of stuff. But we're going to start gently, and then we're going to move up. Now, can you do me a favor? Over there is a doohickey in the corner, actually, that if you click, you'll subscribe to my YouTube channel. I will greatly appreciative if you can do that. The more subscribers I get, the more it actually makes me understand that you're out there and watching my videos. Right, adding fractions, here we go. By the end of this video, as you can see, I want you to be able to add fractions together with the same denominator, know how to do them with a different denominator, know how to add fractions with mixed numbers. Right, we've done all of this in previous videos. So, the trick to adding fractions, as you can see here, is you can only add fractions together when the denominators are the same. That's the big hint. Whenever you see a pair of fractions, say to yourself, is the bottom of my fraction the same? And if your answer is yes, then touche, you is done. So let's have a look at a really basic example. And in fact, I'm going to show you here where people tend to make lots of silly mistakes. Now, first question, always ask yourself the same thing. Are the numbers on the bottom the same? Of course they are. They are both 2s. Now, this is what people tend to do, and they make such a fundamentally silly mistake. It's cry, I do. So this is what they do. They go, oh, okay, the bottoms are the same, and I remember that you now add all of those things together. And what they say is they go that 1 plus 1 is 2. So they literally say, well, this 1 and this 1 adds together to give me 2. And then they go divided by, and now we're going to add the 2 and the 2 together, which will give me the value of 4. And I go, really? And they go, and I go, but why? I say, what happens when you cancel that down? They go, oh, I get a half. And I'm like, well then hold on a moment, because surely a half plus a half can't possibly be a half. And that's the silly mistake that people tend to make. And maybe it's the heat of the exam, I don't know. But my advice to you is, when you add fractions, when the bottoms are the same, they actually stay the same when you add them together. It's the tops you add together. So 1 plus 1 is 2, and then 2 divided by 2 is 1 whole 1, because if anything divided by itself is 1 whole 1. And I tend to like drawing diagrams. So if you imagine that that is really badly 2 halves of a cake, when I put those 2 halves together, oops, let's do that properly, what do I get? I get a whole cake. And I love cakes or pizzas or anything that circles because it helps me. So what about the next example? Ask yourself the question, are the bottoms the same? Yes, they are. So they are the same, and so they add and they stay the same. So the bottom stays the same, but we add the top 2 numbers together. So what do we get? We get 1 plus 4 gives me 5 on 3. Now, a little bit later on, we're going to talk about mixed numbers, but let's do it now. All right, I've got 5 divided by 3. Now, that's a top-heavy fraction, which is like, do we have those in maths? Yes. Can we turn them into something more readable? Yes. Now, what I say to myself is then, I've got 5 lots of 1/3 of a cake. I've got 5 thirds of a cake. Well, hold on a moment. If I've got thirds of a cake, how many thirds make a whole one? Well, hopefully we'll go, there's 1, 2, and 3 thirds make a whole one. So I've got 1 whole cake. But I've got 5 thirds. 3 of them have already gone. How many thirds have I got left? I've got 2 thirds of a cake. So there we go. 5 on 3 is the same as 1 and 2 thirds. And you can actually reverse that process. Okay, let's have another example. Can we add together these 2 fractions? I should, Coco. The bottoms are exactly the same. I've got a 5 and a 5. So what happens? They stay as a 5. 1 plus 3 gives me 4. And do I need to cancel that down? Nope. Can I turn, is it top heavy? Nope, because the bottom number is bigger than the top number. And I am done. And it doesn't always have to be with two fractions, believe it or not. We can actually have 3 fractions or 4 fractions. So let's do, are the bottoms all the same? Yes, so they stay the same. And then we just add the top numbers together. So 3 plus 5 plus 6. Well, 3 plus 5 is 8, 9, 10, 11, 12, 13, 14. We have 14 on 11. Oh, hold on a moment. Our top number is bigger than our bottom number. So let's think about what we've got here. We've got 14 lots of 1 on 11. So here's the question. How many 11ths make a whole one? Well, the trick really is looking at this one here. How many whole ones do we have? Well, there's 11 11ths in a whole one. But how many have I got altogether? I've got 14. So how many must I have left over? Well, 14, take away those 11, gives me 3 on 11. So therefore, ladies and gentlemen, we can write that as 1 whole 1 and 3 11ths. This fraction stuff is awesome. Now, that was obviously the easy stuff. What are we going to do now? Well, we're going to look at fractions with different denominators. Now again, we can only add fractions together when the bottom numbers are the same. Now in this situation, we've got a 5 and we've got a 2. So I can't actually add those together at this moment in time because the numbers are not the same. But what I now need to do is find what we call our lowest common denominator. Now again, if you've had me or you've watched the previous videos, you know how to do this. I'm going to write down my 2 times table, 2, 4, 6, 8, 10, 12. And I'm going to write down my 5 times table, 5, 10, 15, 20. And I'm looking for the first number that is the same. And as it turns out, we have 10 is the first number. So that's my lowest common denominator. So this is the bit that I'm now going to say, well, I'm going to change that to a 10, and I'm going to change that to a 10. I've got 2 fractions now. Both of them are going to have 10 at the bottom. So moving this up just a little bit, I'm now going to try and turn 1 on 5 into something divided by 10. And how do we do this? Well, we say, how did I go from 5 to 10? Hold on a moment. I multiplied by 2. So what do you have to do to the tops? Absolutely the same. And what's 1 times 2? It is 2. So 1 on 5 is the same as 2 on 10. Now, what about my next one? I've got 1 on 2 has to become something on 10. Let me think. I've got a 2 and I've gone to a 10. How have I gone from 2 to 10? Well, I've times by 5. And what do I have to do now? Yep, I have to times the top by 5, which gives me 5 on 10. And there we go, we have 5 on 10. Now, do we have the bottoms the same? I should cocoa, we do. So ladies and gentlemen, what do? The bottom stays as a 10, but I can now add the top. So 2 and 5 gives me 7, and there is my final answer. Is it top heavy? Nope. So I leave it absolutely as it is. We're going to be guns at this by the end of this video. Right, well, what we got? We got 3/4, 5, 6. Right, can we add those numbers together? Are they the same? Nope. So I need to do some common denominator stuff. Right, so we've got a 4 and we've got a 6. So we're going to do 4, 8, 12, 16, 20, and we've got 6, 12, 18. Hold on a moment. I don't need to go any further because I've already found my lowest common multiple. So we've got 2 fractions added together, but this time they're now going to have 12s on the bottom. Right, let's go back. So we've got 3/4 has to become something on 12. How do I go from 4 to 12? Times by 3. And this is where your times tables come in really, really handy. Yeah, you're never going to add things to the bottom. You're never going to add things to the top. It's always, how do I go from number to the next number, timesing them together. So times the bottom by 3. We have to times the top by 3 to give me 9. And so there we go. We have 9 on 12. Right, what's the next fraction? We've got 5 on 6 is equal to, again, something on 12. How do I go from 6 to 12? Times by 2, yep. So I'm now going to times that by 2, which gives me 10. And check, are the bottoms now the same? I should go. So in which case they stay 12s on the bottom, but I add the top together. So 10 plus 9 is 19. Am I done? No, because I've got a top-heavy fraction. Right, so 19 on 12. So I've got one whole cake. That's taken 12 pieces. How many pieces are left? Well, I've got 19. I've taken 12 out to make a whole cake. That leaves me 7 pieces left. And there we go. So I've got one whole cake and 7/12 as my mixed fraction. Now, I'm going to show you a shortcut. And the thing about shortcuts is they make me really, really nervous. Why? Basically speaking, if you use them incorrectly, then they actually, they mess up all sorts of stuff. But here is the shortcut if you want to use it. Now, the easiest way to find the lowest common denominator is actually to take 4 and 6, take the two numbers, and multiply them together. That's the quickest and easiest way. So again, if you have goods times tables, you're going to be able to do this like a gun. So 4 times 6 is 24. So they go over 24 and 24. Now, here's the bit that tends to throw people. I have got to now multiply this value here by 6. Why? Because this number under here was also 6. So we actually end up multiplying cross corners. And this is why this trick is horrible. Yeah, get it wrong, it all goes horribly wrong. But, so 3 times 6 gives me 6, 12, 18. And then what do I multiply this 5 by? Well, its opposite corner there, which is 4. So 5 times 4 is 20. Then, are the bottoms the same? Yes. So we get 18 plus 20, which is 38 on 24. Yeah, that's top heavy. I know, I can get it now. So this value here is top heavy. So what I'm going to say to myself is this, right, okay, I've got one whole cake. We'll have 24 pieces. How many pieces take me from 24 to 38? 24, that would be 14 pieces, which isn't enough to make a whole cake. So we get 14 on 24. So we get one whole cake and 14 on 24. But what do we notice about 14 and 24? They're both even numbers. So we can now cancel down. What goes into 14 and 24? Well, my advice is always halve them. So we get 7 on 12. And I happen to know that that can't go any lower. Now that's a shortcut. Maybe the more you practice the stuff earlier, the shortcut will actually make some sense. And then the final part of this video, ladies and gentlemen, is, yes, mixed numbers. Now, there are two ways of doing this. And I will do them, I'll have a go at doing them both ways. The first thing is, I don't like mixed numbers. I really don't. I've got 3 and 2/3. So we've got 3 whole ones, and I've got 2/3 of a whole one. Now, actually, as it turns out, highlighting it, that this number here, this bottom thing here, is the most important to me, because it's telling me I'm dealing with thirds of cakes. So 3, 1, 2, 3 whole cakes. So I've got 3 whole cakes, and that's got 3/3, 3/3, 3/3, and I have to add on 2/3 as well. Yes? So 3/3, 3/3, 3/3, and 2/3, 3, 6, 9, 10, 11. So I now have 11 on 3. See what I did there? What about my next one? Again, look at the bottom number. It's 3 again. So I'm dealing with thirds, but this time I have 4 and 2/3. So going back to my cake analogy, 1, 2, 3, 4 whole cakes and 2/3. So we've got 3/3 in there, 3/3 in there, 3/3 in there, and 3/3 in there. So I've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 14 thirds in total. So I'm going to add 14 thirds. Right, let's ask ourselves the question, are the bottom numbers the same? They are indeed. So I can now make them all over 1, 3, and I just add my top two numbers together. 11 plus 14 gives me 25 on 3, which we now know is top heavy. And this is where I have to now do it the other way around. I've got 3, 6, 9, 12, 15, 18, 21, 24. So 8 whole cakes gives me 24 of those thirds, and then 25 gives me the 1 left over. Now, mixed numbers are awesome, but you really do have to practice them. And this is going to be my last example. Now, all these examples came from the Cambridge Essentials textbook series, which I'm so stoked that Cambridge have allowed me to use. So, right, let's have a look. Are the bottom numbers the same? No, they're going to be tricky here. So, what do? We're going to turn it into top heavy. But now, this first fraction here, I'm dealing with 6. I've got 2 whole cakes, and I've got 5 sixths left over. But there's 6 sixths there, and 6 sixths there. So those are my 2 whole cakes split up into sixths. So 6 and 6 is 12, plus 5 is 17 on 6. Okay, so there we go, 17 on 6. And we're going to add 2 3 3/4. Right, let's see what that one is now. That's quarters this time. So we've got 1, 2, 3 whole cakes and 3/4. So there's 4 quarters there, 4 quarters there, and 4 quarters there. So 4, 8, 12, add those 3 4s together, 12, 13, 14, 15. That gives me 15 quarters. Right, 15 quarters. Right, now, are the bottoms the same? Still no. So I've got to find my common denominator now with 6 and 4. So let's do my 4 times table. 4, 8, 12. My 6 times table, 6, 12. Whoop, there we go. So 12 is going to be my lowest common denominator. So 12 plus 12. Now in this situation, I'm going to work down the page just to give us a little bit of room. Right, we've got a 6 on the bottom here and a 12 on the bottom here. How do we go from 6 to 12? We double it. We're doing equivalent fractions. It's 2 times bigger. So what I do to the bottom, I must now do to the top. What's my top number? My top number is 17, which I'm now going to have to double, which gives me 34. Yeah. What about my next number? So this was a 4 and it's turned into a 12. How many times bigger is that? It's 3 times bigger. So I have to make the top 3 times bigger as well. So 15 times 3 is 45. Are the bottoms the same? They are indeed. So they stay 12 on the bottom. And I have 34 plus 45, which gives me 79 on 12. Is that top heavy? Yup. Okay, so now we have to do some cancelling down. 12, 24, 36, 48, 60, 72. So it's giving me 72, gives me 6 whole ones. 72, 73, 74, 75, 76, 77, 78, 79, and 7/12. Now that's one way of doing it. If I scroll back up, let's see if there's a different way of doing it. Okay, so I'm going to rewrite out the question and say, well, let's say 3 2/3 plus 4 2/3. Well, what the question says is, well, we now know we've got 3 whole cakes and 4 whole cakes. Those are the whole numbers dealt with. And we've got 2/3 of a cake and 2/3 of a cake. Can we make this simpler for ourselves? Well, yes, because we know that 3 plus 4 is equal to 7. So there we go, 7, thank you very much. And now we're just going to add my fractions together. Are the bottom numbers the same? Yes. So I'm now going to end up with thirds, and then I can add together my top numbers. And 2 plus 2 gives me 4. And is that my final answer? Well, no, because 4/3. So what is 4/3 as a mixed number? Well, 3/3 make a whole one, and 4 gives me that one there. So that gives me 1 1/3. So that's the same as 7 plus 1 1/3, which gives me 8 1/3. Now again, you may like doing it that way, maybe not. You've still got mixed numbers. What about the next example? Let's simplify this one. So we had 2 5/6. Let's write it out again here. 2 5/6 plus 3 3/4. Right, let's scroll that up a moment so that it's all on the screen. So we'll split that up and we'll say, well, okay, we now know that our whole numbers are 2 and 3. So let's write that as 2 plus 3 plus, and we know our fractions are 5/6 3/4. So add 5/6 and add 3/4. Right. So we now know that 2 plus 3 we can put as 5. And now we've got to do our fractions. Are the bottom numbers the same? Nope, 6 and 4, but we've already worked out that 6 and 4 both go into 12. So we can now say, well, okay, that becomes on 12, and that becomes on 12. So trying to keep this as equivalent fractions, what do? We've looked at this bottom number. Let's highlight it in a different color. We've gone from 6 to 12. Have we done that? We've doubled it. So we need to double our top number here. So 5 times 2 gives me 10. And now let's look at the next one. Let's do this one in blue. That's gone from 4 to 12. How have we gone from 4 to 12? You've made it 3 times bigger. So I now need to make the top 3 times bigger, which gives me 9. So we end up with 5 plus, the bottoms are now the same, and that becomes 19 on 12. Oof. Just giving myself a little bit of room. We now then know that that's going to be 5 plus, what's 19 on 12? Well, how many 12s make up a whole cake? Well, 12 makes up one whole cake, and we've got 19. So 19 take away 12 gives me 7, which gives me my answer of 5 plus 1 is 6, and 7/12. And was that what we got before? I should cocoa. Now, that's pretty much the end of this lesson. And I have to say, what do you need to do? Practice, practice, and practice. To be honest with you, ladies and gentlemen, if you can add together all of the fractions with the same denominators and then actually get these ones with different denominators, the mixed numbers comes. You'll get this, but it's practice. And yes, you'll make mistakes. Look at the person beside you. Have a go. Compare. Go, well, how did you get that? And at some point, very soon, if it hasn't already done so, click, you will get this right. Okay, I am MaffsGuru, otherwise known as Darren. Thank you so much for tuning in. If you haven't already done so, can you do me a favor? And, oh yes, subscribe. You don't know how? Well, there's not only that doohickey in the corner, there's a doohickey over there. But I'm signing off. I look forward to seeing you in the next video. This is MaffsGuru signing off. Take care. Bye-bye.